In this video, let's take a look at this transistor circuit and try to figure out how this works and what are the currents and voltages on the various ports of the transistor. Okay, one of the first things that we want to do when we want to use a circuit like this is to figure out which mode it is working in, right? Because if you figure out that it's in the cutoff mode, then you know how the transistor behaves. You can replace the transistor with the model uh, in the cutoff mode, and you can calculate the inputs and the outputs. And similarly, you can do for the active and the saturation mode. But you don't know which mode a transistor works in. Well, you start to get a kind of an intuitive feel for it uh, as you start to look at more and more circuits. But let's say you don't know what mode it is in. So what do you do? Okay, my suggestion to you would be assume your transistor is in the active mode. Okay, and calculate the currents and the voltages, and then in the end, make sure and see whether the voltages, the base collector voltage and the base emitter voltage, match the active mode. Okay, so let's try that in this problem. So I'm going to assume that this transistor is in the active mode. Okay. So if it is in the active mode, uh, so this is the base, this is the collector, and this is the emitter, right? So if it is in the active mode, what do we know about the active mode? We know that the base collector junction is reverse biased and the base emitter junction is forward biased. And when this junction is forward biased, we know that the drop the drop across this diode is zero point 0.7 volts, right? Which means if the voltage at the base, which we are given here, is 4 volts, the voltage at the emitter will be what? It will be 4 minus 0.7, which is 3.3 volts. Okay. Now, if VE is 3.3 volts, what will be the current flowing through uh, through this resistor? The current flowing through this, and let's call it IE, is going to be 3.3 volts divided by 3.3 kilo ohms, which is going to be 1 milliamperes. Okay. Now, if this is 1 milliamperes, we can assume that the collector current is same as the emitter current, right? Because you can do that uh, in the in the active mode, and therefore this collector current, sorry, this needs to be IC, is also equal to 1 milliampere. Now, if this is 1 milliampere, what is the voltage VC going to be? It's going to be 10 minus 4.7 kilo ohms times 1 milliampere. Okay, I'm just going to write it so that times 1 milliampere, right? And that is going to be equal to 10 minus 4.7 volts, which is equal to 5.3 volts. So that's your VC. Now that you've got the collector voltage and the emitter voltage and the base voltage, let's look at whether our active mode assumption was valid or not. Okay, so what is VBC going to be? So here you have 5.3 volts, here you have 4 volts. So the voltage here, this base collector junction is definitely reverse biased, right? Because this is at a higher potential. The collector is at a higher potential than the base. So this is reverse biased. So that's good. And of course, the base emitter junction, you have 3.3 volts and 4 volts. So this is forward biased. So yes, so this fits the assumption that we made that this is in the active mode. And therefore, the solution is valid. If you want to calculate the base current, which is IB, you can calculate it, right? Because IB equal to IC over beta, and let's assume that beta is 100. In that case, you get something like 10 microamperes, which would be the base current. Hope that makes sense.